Hi, welcome to this tutorial. I'm going to solve question 4b from NECTA 2017 Basic Applied Mathematics paper. It is from 6th level and the topic is differentiation from first principles. Okay. So I have already completed 4a on my earlier videos and now we are doing 4b. You do not need to have done 4a in order to do 4b, so you can continue to listen and then go and watch 4a afterwards. Okay, so you're asked to find dy dx given this function here from first principles. Right, so differentiation from first principles is all based on finding gradient at a point and the solution to that, and then when you apply a limit when delta x approaches 0, that will give you dy dx. So just like what you've always have been doing, gradient is change in y divided by change in x. So you can think of it, this is your y2 and this is your y1, divide by change in x. The only difference now you're going to apply is the limit when delta x approaches 0. Okay, so let's just do that. So if we just do this part first, so function of x plus delta x minus function of x divide by delta x. Okay, what does this give us? Right, so how do we get this part here? All we have to do is substitute x plus delta x wherever we see x. Okay, so 4, and then we need to do x plus delta x, and then it's a cube, plus 3, and then now instead of x, x plus delta x, and then minus 4. So this is this part done, the first part, and then from that we need to take away our original function. So take away 4x cubed, let's just write that down here, and then take away positive 3x, so take away 3x, and take away negative 4, which will end up with a 4 plus 4. Everything divided by delta x. So I can see there's minus 4 and a plus 4 there. So let's get rid of those two to start with. And now we're going to expand. This is a triple bracket, basically. It's written like this. So what do you get when you expand a triple bracket? Well, you get x cubed plus 3x squared delta x plus 3 x delta x squared plus delta x cubed. Okay, then we have our plus 3x. In fact, we can get rid of plus 3x because we have minus 3x here, but then we are left with plus 3 delta x, and then we are left with take away 4x cubed. Everything divided by delta x. Right, so I can see 4x cubed here and minus 4x cubed, so that will go, and then I'll have 4 times 3, so 12x squared delta x. Again, I'll have plus 12 x delta x squared, and then I'll have plus 4 delta x cubed, and then what else do I have? I have plus 3 delta x. You need to take your time when you do this, and you need to I would say triple check, okay, because this is where it starts to go wrong. Okay, now we need to divide with delta x. What do we get? Well, if we divide with delta x here, we just have 12x squared. If we divide by delta x here, then we have plus 12x delta x. If we divide here, then we have plus 4 delta x squared, and 3 delta x divided by delta x, we get plus just 3. Okay, so delta x is now gone. So remember, this is your function here, function of x plus delta x minus function of x divided by delta x, giving you it's giving you all this. We're now going to apply the limit. Okay, when delta x approaches 0, what does this become? This becomes, well, there's no delta x there, so that just becomes 12x squared. Well, this becomes 0, so 12x times 0, that's just 0. This, again, delta x is 0, so 4 times 0 squared is just 0. And then we just end up with plus 3. So therefore, your dy dx is going to be equal to 12x squared plus 3. Okay, so the key thing here is to make sure you double check all your terms and all your numbers, because that's where it can easily go wrong. Thank you for watching, and see you again.